This presentation is a continuation of my last video in which I gave a detailed information about Mercator's projection. And the fundamental of a Mercator projection are the meridional parts. And meridional parts are required to calculate the courses or the true tracks on Mercator charts. Before going into the detailed math, I want to note here that there are no requirements to derive this expression for obtaining a master mariner's or navigation officer's qualification. Mariners use nautical tables at sea and in colleges, which tabulate the values of meridional parts for solving practical navigation problems at sea. However, this formula is a great aid to developing electronic navigation systems or configuring programmable calculators for chart work, etc. I derived this expression for my Master of Science degree in software development. Let's examine this illustration where we can see a rhumb line on a sphere and the same rhumb line on a Mercator chart. The ratio of the chart length on the equator EF to the geographical distance E prime F prime when expressed in the same units is some fraction such as alpha. If, for example, E prime F prime is 1 minute of arc, that is 1 nautical mile, and EF on the chart is equal to 1 millimeter, then EF represents approximately 1,855,325 millimeters on the Earth, and that is the scale of that chart normally printed on the face of the chart. Going back to the departure formula, the parallel C prime D prime is equal to the departure, which is E prime F prime on the equator times the cos of phi, where phi is the latitude. E prime F prime can be replaced with the chart length, which is the scale alpha times EF. Since EF is equal to CD on the chart, therefore the expression becomes C prime D prime equal to alpha times CD times cos of phi. And after a small algebraic transposition, the expression can be written as CD divided by C prime D prime equal to 1 divided by alpha times secant of phi. If the rhumb line track C prime H prime is sufficiently small, then the two triangles C prime H prime D prime and CHD may be considered plane right angle triangles at D prime and D respectively. These are the two similar triangles, therefore ratios of their tangents will be equal. Since CD over C prime D prime is equal to 1 over alpha times secant of phi, therefore, we can write this expression for DH equals D prime H prime times 1 over alpha times secant of phi. The meridian length DH on the chart is represented by a line proportional to the actual length of the meridian, multiply the secant of latitude. The actual distance between D prime H prime on the Earth is the circular measure D lat, or difference of two latitudes, in radians, or 180 degrees by pi times d lat, and so we can multiply that by 60 to express that in minutes of an arc. And here is a small explanatory note how to convert pi radians to minutes of an arc. We can substitute the value of D prime H prime, which is the D lat, into this expression, and so the DH becomes 180 degrees times 60 divided by pi times D lat times 1 over alpha times secant of phi. We can slightly rearrange by writing 1 over alpha outside in this expression. Note that this expression is showing the value in the nautical miles because we took D lat or D prime H prime by substituting their values. But 1 minute of an arc of a chart represents alpha millimeters or whatever scale units are. Therefore, we can multiply that expression with the scale of the chart. Here alpha and alpha cancel out and the expression becomes independent of any units of the chart. So over horizontal scale along D long on the equator or DH along the meridian becomes similar. If D lat and therefore DH are infinitesimally small, then the meridional parts for any latitude, say L, are found by adding all the components as derived in the above expression from the equator to the latitude in question, which is given by the expression 10,800 over pi with integral from 0 degrees to the latitude of secant of phi with respect to phi. This mathematical expression gives number of meridional parts for any latitude for a true spherical Earth. It's very important to note that meridional parts involve chart lengths or number of pixels on a computer screen. They are not in any way connected with the distance on the Earth's surface, which is measured in nautical miles. In the remaining section of this presentation, I'm going to apply simple calculus, that is integration of secant, property of natural logarithm, and some trigonometric identities to give the above expression its final and useful form, which can be used in computer programming, in the programmable calculators, or for everyday practical purposes at sea. Integral with limits of the function of secant of phi is equal to the natural logarithm with the limits of secant of phi plus tangent of phi from 0 to L. Natural logarithm or logarithm with base e is written as Ln. Solving the limit, we can see that tangent of 0 is 0 and secant of 0 is 1. So the last expression becomes natural logarithm of 1, which is also 0. So whole expression becomes meridional parts equal 10,800 divided by pi times natural log of secant of latitude plus tangent of latitude. Here I use simple trigonometric identities to further simplify the expression. Even though they look very complex, but they are very simple trigonometric identities. For example, sine squared theta plus cosine squared theta is equal to 1, or cos theta divided by 2 is equal to cos squared theta by 2 plus sine squared theta by 2, and sine theta by 2 is equal to 2 sine theta by 2 cos theta by 2, and so similarly, even though they look complex, but they are simple. Here is some application of simple algebra. For example, a square plus b square plus 2ab is equal to a plus b whole square, and the factorization of a square minus b square equal to a plus b times a minus b. So the cos L by 2 plus sine L by 2 whole square, one factor crosses out with the bottom cos L by 2 plus sine L by 2, and now we are left with cos L by 2 plus sine L by 2 divided by cos L by 2 minus sine L by 2. And this is the identity for the tangent function. Cos L by 2 plus sine L by 2 can be written as 1 plus tangent L by 2, and the bottom one, cos L by 2 minus sine L by 2, can be written as 1 minus tangent L by 2. I'm using pi by 4, which is equal to 1, to further simplify this expression, and eventually, as we can see, the meridional parts become 10,800 divided by pi times log of tangent of pi by 4 plus L by 2, and pi by 4 is actually 45 degrees. Therefore, we get meridional parts equal 10,800 divided by pi times natural log of tangent of 45 degrees plus latitude divided by 2. This presentation concludes an introduction to Mercator's projection and meridional parts formula. In my forthcoming series of presentations, I'm going to talk about great circle and composite great circle sailings. That is the application of spherical trigonometry for ocean passages, and which is also used for celestial navigation using the heavenly bodies, sun, moon, planets, and stars.